solving systems of equations by using elimination. In earlier videos, we solved it by graphing, and we did by substitution. Now we're going to do my favorite way, which is elimination. So remember, graphing is best when you have a nice graph and if they're already in slope-intercept form. Substitution is nice when you already have a variable that's by itself, isolated. Elimination is nice for all the other times. We're going to solve by elimination. Here's our first example. Elimination is when we want to eliminate a variable. If you look here, since we have an x here and we have a negative x there, if I just add these two equations, we just add down, we get negative x plus x, those cancel out, and we get y plus y is 2y, and we get 1 plus 11 is 12. We get that. And now we get to solve this new equation by doing math. Let's divide both sides, do some algebra here. Y equals 6. And then, don't forget, much like before, we have to go back and then we have to find x. We have to go back and substitute our found variable into one of these two equations. I'm going to use the bottom one here. We know y is 6. Let's type that in. So this becomes x plus 6 equals 11. Minus 6 from both sides. We have x equals 5. Answer is 5 and 6. Okay, let's look at this one. Similar idea, but now if you notice, the x's one would cancel out, but the y's would. All I'm going to do here is we're going to add down. 4x plus 1x is 5x. These y's cancel each other out. And then 7 plus 3 is 10. You can divide both of these by 5. And we get x equals 2. But much like last time, you cannot just give me one answer. I need the y. Also, I need the pair. Plug into any one of these you want. I think the bottom one's a little easier. We have x plus 2y equals 3. But we found out that x equals 2. 2 plus 2y equals 3. Minus 2 from both sides. I get 2y equals 1. Divided by 2. And y equals 1/2. My answer is 2 1/2. So this is the simplest form of elimination method. All we're going to do is add the two equations, and then one of the variables will cancel out, and we're good to go. Now, it's not always that easy, though. Sometimes when we have equations, like here, when you add them, they do not cancel out. X plus x is 2x, 3y plus 4y is 7y, and then that's 25. I see a lot of kids do this. You cannot solve this. You need something to cancel out. You need one variable left. This gets you nothing. When this happens, we want to create equivalent system equations, like equivalent equations. How do we do that? The multiplication property of equality. Remember, if I give something like this, as long as we multiply both sides by a number, we're going to have an equivalent equation. 4x minus 2y equals 8. These two are equivalent because as long as you do it to both sides, it's still the same equation. And that's what we're going to use here. We're going to want to eliminate one of the variables. So step 1 is line up equations. They're already lined up for us. But if that wasn't the case, you have to put them both in standard form and line them up. Step 2, we're going to multiply if needed. Because sometimes like the ones we did in the beginning, you don't need to. Multiply one or both equations to eliminate a variable. 3, add and solve. And then 4, don't forget to substitute solved variable back in to find remaining variable. So those are the steps. First, we're going to line up the equations, which is again not a really big deal here. If needed, we're gonna multiply by one or both the equations. We're gonna do that in a bit to eliminate a variable. Then we're just gonna add and solve. And then once you do that, don't forget, once you go back, plug it in. And then as always, you can always check your work. Look here, none of these cancel out. Let's get one of the variables to cancel out. Let's try to cancel out the x's here. Let's make them. So what I try to do is try to make it a different variable. I want to be able to add them. So I'm gonna multiply this top here by -1. Because if I do that, these would cancel out. I'm gonna multiply the top here by -1. Let's do the technically plus multiply. That's shorthand for multiplying the whole thing. The -1 by everything here. So as long as you do it to both sides, you're okay. -1 times x is -x. -1 times 3y is -3y. -1 times 11 is -11. We're going to keep the bottom alone. We're not going to do anything to the bottom in this case. We get this. And now we're just going to solve like always. These are going to cancel out. Let's just add them. These cancel. -3y plus 4y is just y. And then -1 plus 14 is 3. So get y equals 3. I solved for one variable. We're already on step 3. Last step, don't forget to plug this back in to solve for your x. It does not matter which one you plug into. As long as you plug into one of these two, you're good. I'll do the top one. It looks a little easier. So I have x plus 3y equals 11, but we know y is 3. We have x plus 3 times 3 equals 11. That's x plus 9 equals 11. Minus 9 from both sides. X equals 2. Remember, we write it in point form. X always goes first. Something like that. We'll do this one down here. Same idea. I want to get rid of one of the variables. You get rid of the x's if you want, or you get rid of the y's. In this case, I think it's easier to get rid of the y's. Because if I multiply the top here by 3, these are already different signs, and the y should cancel out. So if I multiply this top row by 3, so remember you multiply everything top row by 3. 3y minus 6y equals -18. Bottom we're going to leave alone. 4x plus 6y equals 4. Then we add these down, you see the y's would cancel out, and we get 7x equals -14. -18 plus 4 is -14. And then from here we just divide by 7. X equals -2. But remember, we're not done. We have to go back and find our y in this case. I'm going to use the bottom one just because it looks all positive. We're going to use this equation to try to find our y. For x is negative 2, that goes in here. I have 4 times negative 2 plus 6y equals 4. This is negative 8 plus 6y equals 4. We're going to add 8 to both sides. So you get 6y equals 12. And then we're going to divide by 6. We get y equals 2. Our answer is going to be negative 2 and 2. Okay, so that's the idea. Let's kick it up a notch with this one. In this case, there's nothing I can multiply the top row by to get like rid of the x's. If I multiply the top by 3, I get 6. That's not going to cancel out. Same thing with the y's. Nothing's going to cancel out. So in this case, we're going to have to multiply both rows. We want to find an LCD. How can you get these to be the same thing? Let's focus on the x's here. What's the number I can multiply both of these by to get the same number? Well, 2 and 3 both go into 6. So let's focus on that. If I multiply the top row by 3, I get 6x. If I multiply the bottom row by 2, I get 6x. So I'm going to try to make both of these as 6. So multiply the top row by 3, and I get 6x 12y equals 30. Remember, we're multiplying a whole row by 3. And the bottom row, we're going to multiply that by a negative 2. I'm going to do a negative 2 because I like to just add. I don't like to subtract. You can technically subtract these things, but to me it's so much easier just to multiply by negative than add them. Multiply by negative 2 so that these x's here are different signs. They're on opposite teams. I get negative 6x minus 10y equals negative 22. Now when I add these two equations up, these are going to cancel out. I'm going to get 2y equals 8. Let's divide that by 2, and I get y equals 4. Remember, we are not done. We also need our x. We have to plug this guy back in to find x. I'm going to pick the bottom one just because. So 3x plus 5, y is 4 equals 11. 3x plus 20 equals 11. We're going to solve this. Subtract 20 from both sides. 3x equals negative 9. Divide by 3. X equals negative 3. Our answer is negative 3 and 4. That's the idea. Okay, let's skip down for the sake of time. How does infinite many solution or solution works? Same thing as before. Infinitely many is if you have a true statement, something like 0 equals 0, then it's infinitely many. If you get a false statement, something like 0 equals 2, then it's no solution. Same idea. I want to cancel out one of the variables. If I want these x's to cancel out, I have to multiply the bottom by 2. They both become 4. Let's do that. Multiply this bottom by 2. The top here is 4x minus 6y equals negative 26, not changing anything. On the bottom, we're going to multiply all these by 2. We get negative 4x plus 6y equals 26. And if you notice, what happens when I add them? These cancel, those cancel, and these cancel. We get 0 equals 0, which is a true statement. True, spelled correctly. But it's infinitely many solutions. Again, just like all other times, if you get a true statement, then it's infinitely many. If you get a false statement, which I'm imagining this one would be, you get no solution. Okay, now that we know how to do all three methods, let's talk about choosing a method to solve a system. So let's do this first example here. Keep in mind, any method would work. We could solve this by graphing, we could solve it by elimination, we could solve it by substitution. But what's the best, probably the best method to solve it? In this case, I would say substitution. See how this y is by itself? That lends itself to substitution. I could go into this equation down here, and then where the y is, I could plug that in. So it would be 2x plus 7, but instead of y, I'm going to substitute in x plus 13 equals 10. And then we can solve this. If you know a reminder, we distribute. We get 2x plus 7y plus 13 equals 10. Oops, I made a mistake. I didn't actually multiply. 7 times 13 is not 13. A very easy way to make a mistake. This should be 70 plus 21, 91. A very simple mistake to make. Distribute both. Don't forget to actually multiply. And now, next thing we do here is add up like terms if we can on the same side. I'm going to get 9x plus 91 equals 10. Then we're going to minus 91 from both sides. We get 9x equals negative 81. Divide by 9. And we get x equals negative 9. That's my x. Now I need to find my y. Remember, we have to go back, substitute back in. In this case, easiest one to plug in is that one right there. So all we get is y equals negative 9 plus 13, which is 4. So I get 4, negative 9 and 4. X always comes first. So that's substitution method. The next one here, do we notice how they're both in standard form? I would probably do this elimination method. And what would I eliminate? The y is probably the easiest. Notice I could multiply this top here by a negative 2. So I get negative 16x plus 2y, 4y. Man, I'm just messing up all over the place. Equals positive 16. I'm going to leave the bottom alone. 5x minus 4y equals 17. We could add these up. Those y's would cancel out. 16 plus 17 is 33. Negative 16 plus 15 would be negative 11. And we're going to divide this by negative 11. And I get y equals negative, x equals negative 3. I got to find my y. Plug it into any one to find y. Does not matter which one you use. Let's use that one just because. Minus 4y equals 17. This is negative 15 minus 4y equals 17. Add 15 to both sides. Negative 4y equals 32. Divide by negative 4. And y equals negative 8. We get negative 3 and negative 8. That's a little recap of the substitution method and the elimination method. When is it best to use each one? Well, in the first problem here, you already have a variable isolated. That's when you probably want to do substitution method. In the second one here, it's already in standard form for each one. It's already lined up for you. Then that's probably best to do elimination method. Okay, let's do one last problem. Let's do an application problem real quick. So a florist is making regular bouquets and mini bouquets. Each regular bouquet has 5 roses and 11 peonies. Each mini bouquet has 3 roses and 5 peonies. The florist has 118 roses, 226 peonies to use for bouquets. How much of each type can the florist make? So they tell us right here, let X be the number of regular bouquets and let Y be the number of mini bouquets. With that in mind, let's try to make an equation for roses and an equation for peonies. How do roses get used? Well, in the regular bouquet, which is X, we're using 5 of them. That's me 5X plus, how many do we use in the mini bouquets? We use 3 of them. 3Y, because Y is the mini bouquets, for a total of 118. That's how many roses do we have. We're going to do something similar for peonies. In the regular bouquets, it's 11. That's me 11X plus 5 peonies in the mini bouquets for a total of 226. So these are 2 equations. If you look at it, they're both in standard form. So the easiest way to solve this will be by elimination. Let's rewrite it right here. 5X plus 3Y equals 118. And 11X plus 5Y equals 226. So now this one, if I add them, nothing cancels out. I can't do that. We have to eliminate one of the variables. I think the easiest thing to eliminate would be the y's. I think I can make them both be 15. Let's do that. Multiply the top. Let's do it by a -5. And let's do the bottom by a +3. Remember, I always want them to be different signs. Why did I pick the top to be negative? Just because that was smaller. I'm guessing it'll work out for us. The top here becomes -25x minus 15y equals -590. And the bottom here becomes 33x plus 15y equals 678. And now we can add them. The y's would cancel out. On this side, we get 88. Over here, we get 8x. 8x equals 88. Let's divide both sides by 8. And then we get x equals 11. So we have our x. We have to go back, substitute it in to find our y. You can plug into any one you want. Let's say we do this one. 5 times x, which is 11, plus 3y equals 118. This is 55, plus 3y equals 118, minus 55. I get 3y equals 63. Divide both sides by 3, and y equals 9. We're going to have 11 bouquets and 9 mini bouquets. And that's the lesson.